Hello everyone, this is Jay from BTYT Tech Library. Today I'm going to try Ktor, a framework for building asynchronous server-side and client-side application with ease. And while doing that, let me check the differences and similarities with Spring Framework. First, let's create a new Ktor project. We can access the Ktor start page and easily generate a new Ktor project. Like a Spring initializer page, we can also configure the project settings and necessary plugins. Click the download button to generate and download our Ktor project. And when we open and run it, we can see the start message similar to Spring in the Run tool window. Also, we can see Ktor application's super fast startup time. When we access the localhost 8080 port with a browser, we should see Hello World displayed on the screen. About the project layout, we can see that the code to run our application lives in packages under source, main, Kotlin. Configuration files and other kinds of contents live within the source, main, resources folder. And about testing, it has been placed in the package under source test Kotlin, which is we are going to implement later. So if you came from Spring Framework, you don't have to bother to memorize the project structure. Project name can be found in settings.gradle.kts file. Like Spring Framework, configuration modification can be done in application.yaml file. In the case of Ktor, it also supports Hokon file. For example, we can easily change the port via YAML file. Now let's add a new HTTP endpoint. In the project tool window, navigate the routing.kt files, configure routing function, add test1 endpoint to return a simple message in HTML format. In the case of Spring, normally adding the extra method and annotation do the same thing. For example, REST controller on the class and get mapping on the method. Or maybe Spring Webflux functional endpoints is more similar to Ktor's than the annotation-based programming model. Next, let's find out how to configure static content. In the configure routing function, add the following line. Invoking static resources tells Ktor that we want our application to be able to provide standard website contents, such as HTML and JavaScript files. The URL/contents specify the path that should be used to fetch this content. The path myContents is the name of the folder within which the static contents will live. Ktor will look for this folder within the resources directory. Under the source main resources folder, let's create a new directory named myContents and create a new file sample.html. Populate the newly created file page with valid HTML. And after the restart the application, we can check the contents via our browser at /content/sample.html URL. Spring is also not much different. The implementation of the method body relies on a view technology, for example Thymeleaf, to perform server-side rendering of the HTML, which is placed in source main resources templates folder. What about the test? Ktor provides support for creating integration tests, and our generated project comes bundled with this functionality. Create a new directory on the source called test, and a subdirectory called Kotlin. Create a new package inside source test Kotlin called com.btyt. Within source/test/Kotlin and our package, create a new file called applicationtest.kt. And let's write a test for root endpoint. If you're familiar with JUnit, it shouldn't be a problem to write a test in Ktor. The test application method creates a new instance of Ktor. This instance is running inside a test environment as opposed to a server such as Netty. We can then use the application method to invoke the same setup that is called from embedded server. Finally, we can use the built-in client object and JUnit assertions to send a sample request and check the response. Let's write another test for test1 endpoint 2. Okay, today's last checkpoint is register error handlers. We can handle errors in our Ktor application by using the status page plugin. This plugin is not included in our project by default. We could have added it to our project via the plugins section in the Ktor project generator, but since we already created our project, let's add it and configure the plugin manually. Open the build.gradle.kts file. In the dependencies section, add the extra dependency as follows. Click the Gradle elephant icon for reload. Next, install the plugin and specify an exception handler. And add a new endpoint /error test to check if an exception occurs. Add the dependency, install the plugin, and apply it to the code. Quite straightforward, doesn't it? In the case of Spring, for controller-based exception handling, using exception handler annotation to any controller to specify handle exceptions thrown by request handling method in the same controller. Also, using controller advice classes to use exactly the same exception handling techniques, but apply them across the whole application, not just to an individual controller. It's like an annotation-driven interceptor. Today, we tried Ktor framework and checked some differences and similarities with Spring. So, what do you think? I think it's simple, super fast, lightweight, and flexible, built on all the good features of Kotlin. I heard the news that Ktor 3.0 is coming on its way, so if you are interested in it, keep tabs on.